Hi everyone, in this video we are going to talk about a major part of STL, that is containers. Okay, so we will give you an introduction to containers, what all containers are available and in which categories these are divided. Okay, so all the containers in STL are broadly divided into four major categories, and these categories are like these. The first category is about sequence containers, which means these are the containers that store data in a sequential manner. For example, if you take an example of an array, then array always stores data in a sequential manner. Okay, so uh, yeah, let me give you one example. So array always stores this data in a sequential manner, and you can access all the elements of the sequence. Okay, all the elements can be accessed by just iterating over the sequence. The same goes with a vector, the same goes with a linked list, the same goes with a doubly ended queue, same goes with arrays, and same goes with the forward list. Okay, so list is a doubly linked list and a forward linked list is a singly linked list in STL. Okay, so these are the classes, and array vector we will discuss, list and deck is a queue that is doubly ended. Okay, so it has two ends. You can do insertion and deletion, both at the front and the back. Okay, that's called doubly ended queue. Then you have container adapters. So this is the first class of containers. The next class of containers is container adapters. Okay, so these containers although have a underlying data structure that is sequential, but you cannot access all the elements of the sequence. For example, a stack can be built using an array, it can be built using a vector, but a stack gives you only the access to the topmost element. Okay, so the although the underlying data structure is sequential, but the interface, the functions that you will use to interact with the stack object, they are different. Okay, you have a top function, you want to see the topmost element. Okay, then you have a priority queue, that is again it's a heap data structure, and that also uses a array. Okay, and again the interface is different. And similarly, you have a queue can be implemented using a vector, it can be implemented using an array, it can be implemented using a single linked list, but again the interface of the queue is going to be different. And queue is something in which you can add something from the back and you can remove something from the front. Okay, for example, a queue of persons. So if there are persons standing on an ATM queue, so people go and they get added from the queue from the back and they get removed from the front. So these type of containers are called container adapters. And then you have associative containers. Okay, so mostly where you are storing data in a sorted manner. So these are the four containers that store the data in a sorted manner. For example, set. If you contain a set of elements like 3 1 1 5 6, then it's going to store it in this manner 1 3 5 6. So anytime you're going to make queries, you're going to get data in a sorted order. Okay, and since it's going to be a yeah, so data is going to be stored in a sorted order, so most of the operations are going to be of O log n complexity. For example, a BST, if you keep a height balanced BST and you store some data in it, and maybe if you iterate over the BST, you will get these elements in a sorted order. Okay, so we have a set, we have a multi-set, we have a map, we have a multi-map. Okay, so most of these containers are typically some kind of binary search trees like red black trees and all those. Okay, and the fourth is there are unordered associative containers. Okay, for example, you have an unordered map, it is going to store a key value mapping. Okay, and when you iterate over the container, you can get keys in any order, there is no particular ordering. Okay, even if you throw 573 as the key, you may get output 375 as the output. Okay, something like this. So you do not know what is the relative ordering between some elements. Okay, so all those operations where you do not need relative ordering from the between the elements, then you can use unordered data structures because they are quite fast. Okay, for example, hash map, Okay, suppose you go to canteen and you tell the owner, okay, give me Maggie, give me a Coke, and give me let's say sauce also, ketchup. Okay, then maybe he will charge 10 rupee for this, 15 rupee for this, 5 rupee for this. But maybe in the bill it is possible he gives sauce on the first order, then Maggie on the second order, and Coke in the third order. So the goal was to get prices of all these items. The order in which these prices are coming is not important. Okay, so you are able to make a mapping between key and a value, but the order in which these items are getting delivered to you or getting printed on the bill is not important. In that case, you can use some of the unordered associative containers. Okay, so they again have different kinds of functions, and as we go through this course we will discuss about most of these containers in the respective sections. So I hope you got a basic idea of generic programming and containers, and all of these containers are generic. Okay, because they can store data belonging to any data type. They can work with all kinds of data. Okay, so that was a small introduction about containers, and hope to see you in the next section now. Thanks a lot. See you guys.